Hey everyone, in today's video you're going to learn how we can actually graph an equation that's given to us in point-slope form. So let's go ahead and let's get started. In order to do this, you're going to have to be very familiar with the point-slope form. So let me go ahead and write that down. It is y minus y1 equals m times x minus x1. In order to graph a line, we need at least one point and we need to know the slope. Okay, so when they give us an equation like this, y minus 2 equals 4 times x minus 1, we need to know how to be able to take a point and a slope from that. So let's go ahead and start off with the easy one. We know that in front of the parentheses is my letter m. That's our slope. So if I look at this equation and I find what's in front of the parentheses, I'll see that it is the value, or that is the number 4. So that means that my slope is 4. The other thing we need to find is what is our x1 and our y1? What is our point? Okay, what does that equal? Well, in this example again, we sort of just look at the two equations and try to see what's in their spot. So in the location of x1, I see there is a 1. So that means that my x1 is actually 1. My y1, let's look at that. What's in its sort of spot, or what's in the same position? Well, they have y minus 2 instead of y minus y1. So that means that 2 has to be my y1. And that's how I find the information that I need to be able to graph this. I just found my slope and I found my point. So if I go to my graph, 1, 2, that is going to the right 1, up 2. I'm going to go ahead and put a red dot there for that point. That is my point. I know my slope is 4. So we got to remember, what does your slope mean? A lot of times it's easier to remember what it means when we write it in slope and rise over run, okay, in that form. So what we can do is we can change this into a fraction. I can change any whole number into a fraction by putting it over the value of 1. And if we remember that slope means rise over run, we know that the number on top tells me how much to move up or down, and the number on the bottom tells me how much to move to the right or to the left. Remember, positive numbers will tell you to go up or to the right. Negative numbers tell you to go down or to the left. So I got a positive 4, so that means I'm going to go up 4 spaces. And I got a positive 1, which means I'm going to go to the right 1 space. So let's go ahead and let's do that. I'm going to go up 4, 1, 2, 3, 4. And I'm going to go to the right 1 space. And I'm going to go ahead and mark this with another red dot. This location that it leads me to. And you got to also remember that in order to draw a line, you just need 2 points. Since we're talking about a straight line, all I need is to find 2 points, connect those 2 points and extend them, and that'll give me the line to the equation that I'm working with. So let's go ahead and let's connect these as best as we can. And there we have the equation to this line. We have now transformed an algebraic equation into a visual graph. This is what the graph that would represent this. Okay? So very nice. Now, sometimes you got to be careful in how we actually find the point. The slope for the most part will always be easy because it's in front of the parentheses. But sometimes it might be tricky to actually find what this point is. And in this next example, we're going to see exactly why. So here I have another example where I'm supposed to sketch the graph to this equation that's written in point-slope form. So again, I find it best to just rewrite that equation right next to it. Y minus y1 equals m times x minus x1. And again, I can start off by trying to define what my slope is. M is equal to, and I see, okay, again, m is in front of my parentheses. What's in front of my parentheses on this other equation over here? Here I see that it's a -3. So I know my slope has to be -3. But again, when it comes to x1, y1, I see something a little bit different when I'm trying to actually find this. Because here I see x minus x1, and on my actual equation, I see an x plus 2. And we have to sort of stop for a moment and we have to think, well, why isn't it minus 2? Because this does change what our actual point is. Now, if you watched the previous videos, you saw that there were some cases where this actually turned into a positive. And the only way that happened was when I had something like this, x minus some negative number. Let's say -2. If I were to have something like this, this would turn into a positive, and really what I would write down is x plus 2. And that's what's happening here. The reason why we see these positive signs is because they plugged in a negative number. That means the point that they used to write the equation was actually negative numbers. So what this actually means, when I see a positive number here, that means that they plugged in a -2. And when I see a sort of positive 2 here as well, that means that they plugged in a -2. So we kind of have to be careful and ask ourselves, well, how did they come up with this positive sign? Well, it's because they plugged in a negative number. When you subtract the negative number, it turns into a positive. That's why we have negatives here and positives here, because they plugged in negative numbers. And apart from being able to notice that, the rest of the problem becomes the same as a similar problem. Let's go ahead and let's graph our point. -2, -2. I go to the left 2, down 2. And again, very similar with our slope, we have to recall rise over run. So this turns into -3 over 1. And now, since we have a negative value, remember negative values mean you either go down or to the left. Since -3, that means I'm going to go down 3, and this time I'm going to go to the right 1. So let's go ahead and let's go down 3 spaces, 1, 2, 3, and then I'm going to go, so this was like -3 down, and I'm going to go to the right 1 space. And here I have my second point. So I'm going to go ahead and zoom in on that. So I went down 3 spaces to the right 1 space, and now I can connect these dots. Actually, let me do that with a black line. And there we have our line. Okay, and again, we just graphed that equation. That's what the visual representation of this line equation would look like. And that's how we turn a point slope form equation into a graph. So hopefully now you have a better understanding of how we can transform a point slope form equation into its actual graph, the way it looks like. What's the line look like on a graph? Like I said, slope is usually the easiest part to find because it's in front of our parentheses. The point we just got to be a little bit careful with, because we have to keep in mind that if it's a negative number, a negative x or negative y, we're going to see a positive sign in the equation. Now, if we have a negative number, then that means that they just plugged in a positive number, as we saw in the first example. The second example, we saw what happened when they plugged in a negative value for either x or y. So once again, I hope you've learned from this video, and as always, just want to thank you for watching.